Thanks everyone for joining us today. We'll go ahead and get started. My name is Riley DeGarmo. I am a Wolf SSL Business Director for Southern Europe, and I also support our partner ecosystem around the world. I will be moderating today's webinar. Today's webinar is co-presented by Cisco Solution Architect Guido Pinella and Wolf SSL Software Engineer Eric Blankenhorn. And please feel free to email us with any additional questions that you may have following the presentation. So before I hand it off to the guys, I'm going to give you just a brief introduction to Wolf SSL as a company. So Wolf SSL is open source embedded security software focused on providing lightweight and embedded security solutions for desktop, enterprise, and cloud environments, with an emphasis on speed, size, portability, features, and standards compliance. With SSL and TLS products and a crypto library, Wolf SSL is supporting high security designs in automotive, avionics, and other industries. In avionics, Wolf SSL supports complete RTCA D0178C Level A certification. In automotive, we support MISRA C capabilities. For government consumers, Wolf SSL has a strong history in FIPS 140-2 with upcoming FIPS 140-3 support. Wolf SSL supports industry standards up to the current TLS 1.3, for which we were the first commercial implementation, and DTLS 1.2. It's up to 20 times smaller than OpenSSL and offers a simple API, an OpenSSL compatibility layer, is backed by the robust WolfCrypt cryptography library, 24/7 support, and much more. Our products are open source, giving customers the freedom to look under the hood. Wolf SSL was founded in 2004 by Todd Auska and Larry Stefanik when they realized that there wasn't an open source, dual licensed, embedded SSL library available. OpenSSL existed at the time, but there was a demand for an alternative that was easily portable, smaller, faster, available under a clear commercial license, and was equipped with a clean and modern API, offering commercial-style developer support. Wolf SSL was born into this market need with an OpenSSL compatibility layer. The first instance of Wolf SSL was a clean room implementation for MySQL. And today, Wolf SSL secures over 2 billion connections all over the world. We have thousands of OEM customers, dozens of resellers. Wolf SSL is made up of about 40 dedicated employees in 2020, most of which are engineers. And this progress is, of course, supported by a strong partner network with folks like Cisco that we are thrilled to get to collaborate with. Since the beginning, our engineering team has developed several embedded security products, including WolfCrypt with FIPS certification and a FIPS Ready offering, MQTT up to the V5 specification, SSH v2, TPM 2.0, a secure bootloader known as WolfBoot, as well as Java wrappers and JSSE support. We also have commercial support for curl. All of these offerings are accompanied by thorough maintenance and support plans up to the 24/7 level, and we offer full service consulting and engineering services as well. Wolf SSL is dual licensed, which is to say that we can be shipped with your commercial products or licensed in open source projects under GPL v2. And now I will turn it over to Eric Blankenhorn to talk through our key differentiators.
So thank you everyone for joining us. I am Eric Blankenhorn. I'm a software engineer here with Wolf SSL. Today we'll discuss the first libraries that have been integrated with PikeOS, Wolf SSL, WolfCrypt, and Wolf MQTT. So let's take a closer look at the benefits and features of Wolf SSL. All current iterations of the TLS and DTLS specifications are supported. We were one of the first to market with our TLS 1.3 solution. Wolf SSL is focused on providing a lightweight solution that can be used by resource-constrained devices. It can be optimized for environments requiring a small footprint or tight RAM availability. Wolf SSL is consistently smaller than OpenSSL. Finally, here's a list of some of the operating systems that are natively supported with Wolf SSL. So WolfCrypt. WolfCrypt provides support for a wide array of cryptographic operations and algorithms, including hashing functions, block and stream ciphers, authenticated ciphers, public key operations, and password-based key derivation functions. These are utilized by WolfSSL to establish secure TLS and SSL communication and connections, and other products to encrypt, decrypt, and authenticate data. As we mentioned before, WolfSSL supports TLS 1.3. TLS 1.3 provides performance and usability improvements over its predecessor. New features include zero round-trip time with early data, post-handshake authentication, and key and IV update messages. Enabling support for TLS 1.3 connections is as simple as configuring with the correct option. So now I'd like to turn our attention to the certifications that WolfSSL and WolfCrypt have accomplished. Starting with FIPS 140-2, the WolfCrypt FIPS object module compartmentalizes the cryptography component. This allows a distinct separation from the SSL and TLS library, which ensures a safer and more secure environment. By requiring a self-test during power on initialization, the FIPS module can independently verify the integrity of the cryptography software before the application is allowed access. Since each FIPS operating environment is a unique combination of OS, crypto, and hardware, the validation process is often daunting. WolfSSL has made an art of this process, and we offer several options for validation, including adding new OEs, rebranding, and modification of the module boundary. We have the experience to help get your application FIPS certified in a timely manner. So next up, we'll talk about DO-178C credentials. WolfSSL has focused on a few of the cryptographic algorithms for our first round of certification. This was completed earlier this year, and now we are expanding to include other products that are crucial to the industry. Similarly, we chose some of the most utilized cryptography components to update for the MISRA C 2012 rules. All mandatory rules are complied with. All required rule exceptions have been documented. We intend to add more coverage for MISRA C compliance within WolfCrypt and WolfSSL as the most requested features are identified. And that brings us to WolfMQTT. So the WolfMQTT client library allows connecting to brokers that support versions 3.11 and 5.0 of the MQTT specification. The client library is a feature-rich and a wide assortment of examples are provided to demonstrate connecting to different brokers, including Azure, AWS, Mosquitto, and others. WolfMQTT utilizes the best available TLS library to provide a secure connection to protect the Internet of Things, which is, of course, WolfSSL. And that's the end of my slides, so I'm going to turn it over to Guido to present some information about PikeOS.
So good morning, everybody. My name is Guido Pennella, and as said, I'm working as a solution architect here in Cisco. And I come from a long experience in different domains, especially aerospace, defense, and automotive systems. So let me briefly introduce Cisco. So we are number one in Europe for operating system for embedded systems. We provide safe and secure technologies and services for high-end software solutions. We come from a long experience in safe and secure technologies. Now, we have been founded in 1991, so we have almost 30 years of experience in this. We are a member of Thales Group, and last but not least, being a European company, we are also completely ITAR free. So our flagship products are PikeOS, which we're going to see soon some insights, which is a certified R real-time operating system, which has inside a level type 1 hypervisor. But we also have an embedded Linux distribution for industrial environment called Elinos. And then I think the most visible sponsor for this is our best customer, which is Miele, for example. You can see also in our website. As said, we have really proven avionics, automotive, defense, industrial, even medical, railway and space applications, okay? So this is something really tangible, not just slidesware. Okay, now let's move to understand what are the characteristics of PikeOS. Okay, PikeOS is essentially based on a concept called MILS, which is not a military standard, that is without the S. So MILS essentially is an high assurance security and safety architecture, which is based on concept of separation and control information flow. So basically, inside the system, we have a separation mechanism that allow us to have a set of partitions that inside which you can have different level of trustness or safety that runs in parallel. So here, what is very important to understand is that one of the way to achieve this kind of MILS based architecture is the use of a separation kernel, which is exactly the way that PikeOS is doing. Now, take into account that in order to have a separation kernel that strongly provide this kind of separation so that it cannot be bypassed at the level of the software. So essentially, whatever runs into a partition cannot jump around and access the memory or the other elements inside another partition. We need a specific hardware support for this, which means that the current version of PikeOS relies on the presence on the hardware of an IO MMU, which means that for the moment, for example, in the case of ARM architecture, we need a core of type A from A7 onward. But for the moment, we are not yet able to manage, for example, an M type or an R type. I said for the moment because stay tuned and soon there will be innovations about this that we are working on, but for the moment, that's the situation. Now, this is usually our main slide in which we explain the functionality of PikeOS. So essentially, we have three things all together in one. I said we are an embedded R real-time operating system with all the classic stuff of this kind. So we have preemption, guaranteed fast response. What is very important to notice, also take into account for a later point, inside our system, we have an health monitoring subsystem. This is very important because we are able, for example, to monitor the deadlines of the partition and so on. So we can also take care and understand what is happening in a very fine-grained way in the partitions. This you will see will be very important also for later explanations. Then we have our partitioning, as said, as per the MILS approach, which basically means that inside the system we have a type 1 hypervisor. Now, please note, we don't have two products, one with the hypervisor and one without the hypervisor. We have only one product, and inside the product, it has always the hypervisor. Okay. Last but not least, very important, the drivers, instead of the running into kernel space, can be put to run in user space, especially in the partitions. Now, why this is very important? Because we can really handle in an easy way situation in which we have different mixed level of safety criticalness. So that, for example, if we have a situation in which we have a SIL4 partition that need to manage some safety critical actuators and the related drivers, then we can put the drivers related to the actuators and the application in separate partition with respect, for example, a SIL2 subsystem that is dealing with the other aspects, and in parallel with a SIL0 section that is doing, for example, the HMI. So thanks to this partitioning, we can really handle, and we have certification for this, mixed level of safety criticalness, and we will see also how it is very important for the management of the security. So we spoke of the drivers that can be put in user space in different partitions so that we can manage the mixed level of safety criticalness. Of course, in our partition can run our PikeOS native application, which is essentially a C runtime, depending if you need to have a safety certifiable application up to, we will see, DO 178C DAL-A. This can be a little bit restricted in the number of statements that you can use, for example, no malloc and free, quite classically. Or we can extend this with C++ or some POSIX extensions are also available, a lightweight IP stack, so we can run quite a lot of stuff in our PikeOS native section. If this is not enough, we have also the capability to host a guest runtime environment, for example, Ada or Java. So last but not least, we are also able to have an entire guest operating system. So this is, by the way, the list of the elements. You can see it's really rich. And especially in the case of ARMv8, we can benefit of hardware virtualization support. So for the case of guest operating system, if we don't have this ARMv8 architecture with the hardware virtualization support, then we need to run a para-virtualized operating system. For example, our Erinos can easily run, and if needed another Linux, then you need to apply some patches in the kernel and so on. If we are actually running on an ARMv8, then in this case, in defining the hardware virtualization support, we can really benefit and even run a full Android compiled with a standard Android cooking environment, or Linux coming from a Yocto environment, and so on. You can see also that we support also very new and important SoC like the Jacinto 7, which is now very popular in the field of ADAS. We still support PowerPC, which is absolutely important in the field of aerospace, Intel and ARM, of course, and last but not least also Spark, which is still have a very interesting market in the field of the space systems. Okay, so this is the last slide about PikeOS General Cisco. So as said, we have born and bred with safety and security in mind. In fact, with our latest revision of PikeOS, which is the version 5, we are now able to reach the most critical standard levels for safety. For example, the DO 178B DAL-A, the railway system up to SIL4, general industrial up to SIL4, and also automotive up to ASIL-D. And this is honestly, it's really because we have a strong experience in overall these activities, and basically our engineering staff, 75% of it are really direct experience in certification projects. And here you can see a small list of our customer, but you can also go in the website and see. Safety certification is not the only one that we are achieving. We also have security certifications for the old version of the operating system, so the 4.2. The new 5 is now undergoing the same process, which is the common criteria, and for which we got an EAL evaluation of level 3+, which means that we got all the requirements for level 3 plus some additional elements which are normally for level 4. So this is very important because if you are working in a defense system, most probably your final customer will need this kind of certification, so we can provide you an operating system that has this kind of certification. Okay, then now it's time to finally speak of our joint activities with Wolf SSL. So currently, what we are doing together is the support of the Wolf Crypt part of the entire Wolf SSL, and Wolf SSL itself, and also Wolf MQTT. Now, in the case of normal activities, so the joint of the PikeOS and Wolf SSL means that essentially they are enabling us to have a software algorithm base for all these crypto approaches and so on. Now, what is very important to get is the fact that nowadays the key characteristics of some software part, especially for crypto, are now being transferred to hardware into hardware accelerated elements, like hardware security modules or true random number generators and this kind of stuff. So in this case, the sum of Wolf SSL and Cisco is a 1 + 1 means equal 3, because we have a much better benefit in this case, because from one side, we have the software algorithm base very stable from Wolf SSL, and on the other side, the user can benefit from the hardware accelerated drivers that we can provide, which will be, in the case, for example, of Apex and so on, even safety critical hardware accelerated drivers. And together, we can provide a customized version of the what you see, so Wolf Crypt, SSL, or MQTT, which best match the hardware capabilities and in the same way provide you with the least minimal code able to run what you really need to do, which of course everybody that has experience in safety criticalness approaches know that this is a very important point in order to drop the amount of activities in the certification, because there is essentially a relationship between the number of lines of code that you need to manage and certify versus the certification size and type. Okay, now let's move to a specific case and take into an example in which we have an old IoT system in which we have maybe ARMv7 that needs to talk to the rest of the world, and which needs to essentially be able in the same time to be defended by cybersecurity attacks. Now, if you have this kind of situation, most probably you needed to defend your system on the Linux side with a set of approaches that I can define classic. So firewalls, some kernel extensions like Linux as Mac, so the security mandatory control kernel extensions, or SE Linux, and so on. Now, all this stuff, which is by literature can be done, have of course a price to pay, and the price is essentially some burden on the CPU, and if you don't correctly configure the stuff, you can have some impacts on your flash memory too. Now, let's see some tricks that we can do with a PikeOS system. Well, suppose that your element to defend now will be put inside a partition, and this partition will not even have a network interface assigned to it. Actually, the network interface can be assigned to a gateway partition, or maybe two gateway partitions, one for inbound and one for the outbound. And we are going to communicate between the, let's say, inner partition, which need to be defended with the gateway, thanks to some internal mechanism. This kind of internal mechanism we support quite a lot, for example, shared memory or streams, or in the case of the example, something which is very similar to a POSIX message queue that we call queue ports. Now, in this case, what we have done, well, we have abnormally reduced the overall attack surface by an hacker, because if someone will try to enter, will not directly enter here in the element that needs to be defended, but actually land into a small bastion host. De facto, this is a small embedded bastion host, in which it can find a very small amount of memory, C runtime with, depending some capabilities, and probably a POSIX-like message queue. That's it. And so in this way, the risk that if even able to enter, but if it's able to enter, cannot do much. And then later we will see also that we can, in case, detect that something is going wrong, because I can monitor this partition from another and understand that suddenly somebody started to allocate memory and try to open sockets. Then I can also counter react. So this is very important, because essentially we are by design reducing the attack surface, reducing the risk of zero-day exploits, because thanks to the fact that our runtime is very small, we can really take care of it. And we have a dedicated section for inside our company for security that always keep an eye on the possible problems and also react in proactive manner versus our customer. So the system in this way is defended really by design, not simple by cybersecurity stuff, which a lot of time it's on the paper, zero-day defect or being able to enter and so on. So yes, of course, they can still do some denial of service attack, which is always possible, but the situation is not much under control. Okay, now we will see really a small demo, and this is the architecture for the demo itself. Okay, please first note that our system, when you have it, comes together with a Q emulator, so with QEMU. This is honestly a lesson learned from the best in class, like, for example, developing for Android, in which you can essentially, even from day one, without having real hardware, even able to start making your developments, of course, from the functional point of view, but at least allow you already to define immediately partitions, understand the characteristics and so on, even before going to the real hardware. So inside the system, we will see that actually we have three partitions. One that will run, it's an ARMv7, so it's run with our ANO system in para-virtualized mode. And this system, you will see, will have no EP network interface. Then we will have two partitions, one outbound and one inbound. And a small application will talk to this partition via the Q ports I was mentioning you. Please note that the arrow here is monodirectional. So this is exactly true. So the Q port can be made only in one direction to the other. Inside this partition will run an application that from one side understand what is arriving on the Q port and translate to an MQTT message thanks to wolfSSL with the MQTT support, and send this over the air where we have, in this case, a Mosquitto server that is subscribing to the topic that has been published. On the other side, we will see that publishing another topic, this will be actually detected by the inbound partition, which will understand again what has arrived, will change this into an internal message, which is received by the inner partition. Now, this change of protocol, it's very important for the defense of the system, because it's much more stronger with respect simply a firewall. A firewall will understand and analyze the inners of the packets, but will not actually understand the messages themselves. In this case, if the message is not understood because it's not well formed and so on, and try to exploit some hacks at the level of the protocol, simply will be discarded. and will not forward it on the other side. Same story here. If I receive a message on the queue which is not recognized, I will simply discard it. So it's much, much more stronger as an approach with respect to normal firewalling. So we will also benefit of the presence of a service partition. This partition usually allows us to better manage the situation in which we need to debug, in which we are developing essentially, and so on. Usually when we deploy the system really on the field, this partition will disappear. Inside this partition, we have the so-called MUXA, which is a multiplexer demultiplexer, which allow us to enter into the partition from, let's say, backdoor, which is, as said, completely closed in the case of the real running system in the field, and allow us essentially to use some terminals to enter inside the system from another way. Now it's really time to take off for the demo. Here it is. So this is, by the way, our configuration environment. So you can see, so we have integration projects, which are the projects that essentially build the system with the various partitions. Here you see a Linux guest, the outbound and inbound, and the various development tools and the service partition. We can directly define the running QEMU inside the system and also debug from here. So for today, we will just have a small simulation. So now the things have started. So I will quickly connect. Of course, let's see. And yeah, clearly, okay, no, sorry, I think I did an error. Just a second. Let me see. Of course, that's the demo effect. Everybody has it. Okay. Okay. So here you see the MQTT on the outbound has been initialized and the first message has been received here. Here on the other side, the inbound has been activated, and here we are in the inner Linux section. Now, if I say efconfig here, oh, it cannot be done because I have no network device. Okay, let's start Linux Gateway application. So this is a very simple application. For example, I can send some basic data. Here you see this first message has been recognized here, and then has built a new message that is of course detected by the Mosquitto subsection here. Or I can publish some message here. So hello webexers. And this is detected here by the inbound. And in this case, I need to explicitly look on the queue and everything has been correctly received. Or I can also send some, I don't know, system status message. For example, I say overall system status operational, sensor status operational, temperature idle, and voltage idle. And you see, again, detected here, and we have been able to send the same stuff here. Or I can also simulate, for example, to send a strange message. It's arrived 55 horrid message, and of course this is not propagated because the system is reliant on the fact that nobody will pass unless has been correctly understood. So in this way, we have, as said, much better capabilities with respect to a simple firewall. And as said, in the end, we don't need that much amount of resources. We can really simple run on an v7, take into account that the various PikeOS inbound and outbound use really a few megabytes of memory, only memory, not even flash. And in this case, so they will only store very, let's say, use very few stuff on the site, which will essentially allow you even to retrofit an old ARMv7 system with limited resources with our system, and of course a newer one which much stronger resources will of course be even better. Let me show you also two advanced cases. So do you remember at the very beginning I told you that one of the characteristics that we have is also to have an health monitoring subsystem that is running in our PikeOS. Now, suppose that we have the situation down in which we have, for example, a much better and stronger, newer CPU with more RAM and so on. But what is very important to notice is that we can build, for example, another partition that is silently overwatching what is happening in these communication partitions. And as I can define, for example, a partition be a privileged one, which essentially means that in case I am able to activate and deactivate other partitions, or reboot, shut down, and so on, because know that not all the partitions are mandated to run in the same time, okay? So essentially I can build an intrusion detection subsystem that will, for example, understand that something is going wrong into the inbound because the memory suddenly start to be larger than the normal allowed, and somebody try to open additional sockets. So there is, let's say, a strange behavior between quotes, and then I can take countermeasures for this. Or, for example, I can isolate the access to the hardware security module in a completely different partition. This is very useful, for example, when we have to do over-the-air updates. For example, assign this partition a storage area, so where the over-the-air update can land, will be securely checked thanks to the hardware security module with hardware acceleration. And then we can apply the over-the-air update. Take into account, for example, that if you have this SIL4 partition with the actuators, and you have the classic environment in which you have two partitions, the old one, which is actually inactive, and the new one. So, for example, in the case this security checker can install the over-the-air update in the other partition, and we can switch the two partitions, take into account that to switch a partition is really few milliseconds. So essentially, you will be able to perform over-the-air updates with a downtime of milliseconds. So a very high level quality of the overall capability of the system to continuously run and provide approach to manage the actuators and so on. So minimal downtime will be like in milliseconds range. Okay, so let's now close. So what we have seen is that thanks to the joint forces of Wolf SSL and Cisco with PikeOS, we can really provide secure, hardware accelerated, safety critical, certifiable embedded systems for different range of application, ranging from industry, industrial IoT, IoT, avionics, railway, automotive, and so on. Thanks to the flexibility of the architecture, that thanks of it, we have the hypervisor directly inside the system. We can manage several configurations with mixed environment from point of view of security and safety. And thanks to our security by design, together with the crypto support and TLS support by Wolf SSL and Wolf MQTT, we can really benefit of the stronger possible defense approach. And you can also retrofit all systems in a very simple way so that they can really bring a very good level of resilience against remote attacks. Now, please note one key point, which is the also conclusion of my presentation. We always have one product. We don't have the product certifiable and the product non-certifiable. We don't have a product with the hypervisor and without the hypervisor. We don't have a product that supports Wolf SSL and a product that does not support Wolf SSL. We have always one product. So even if you don't need it, you will receive a system which is able to withstand the most high level of safety criticalness, independently if you need it or not. If you need, of course, we can provide you all the certification artifacts and so on, and help you also during the certification activities. Take into account that, for example, for the specific application, we also manage strong connection with the hardware vendors and do even CPU errata analysis and provide a lot of information which are needed to reach, for example, the DAL-A. But please, we have only one product.
Thanks so much, Guido, for presenting on the Cisco side. And Eric, thank you for presenting for Wolf SSL, our joint technology. Please also follow Cisco and Wolf SSL on our socials. You can see some links there. We do want to thank you all so much for participating today and for your attention. We can't wait to learn more about your embedded projects and support your progress. Thanks again to Daniele, thanks again to Guido, and everybody have a great day.
Thanks everybody for hearing us. Bye-bye.